All right, so on a question like this, we're looking at a 45, 45, 90. They're telling me the hypotenuse is 30. So this is kind of the, I'm going to walk you through the kind of thought pattern that I would go through on all of these, but eventually I'm going to kind of shorten this process. I'll show you what I mean when I get there, but like I'm not going to do this every single time, but this is kind of what you should kind of be visualizing. If this is the triangle that I want to deal with, I want to draw the same exact triangle, but instead of the values that are presented inside the problem, I'm going to write down how those values should relate to one another in every single 45, 45, 90 triangle. Does that make sense? Okay. So that's, you're going to hear me say, draw your template. That's drawing my template. Okay. So I know, I'm going to use a different color here, that this should be in, that should be in, and that should be in radical 2 for every single one of our 45, 45, 90 triangles. Is that all right? Okay. So the next thing then is to either physically or visually line these two triangles on top of one another. So if I were to take this triangle here, bear with me, the PowerPoint's kind of frozen. There we go. Well, there we go. So I'm going to take this triangle, and I'm going to lay it on top of that one. That makes sense? So, because they're congruent triangles, the way I made them, they were congruent. If they're congruent, what numbers, or I guess expressions, lay on top of each other so that I get an equation that I can solve? 30 and in radical 2, right? So if those two triangles were congruent, 30 and in radical 2 were congruent, so that means that those values are equal. So 30 equals n radical 2. Now, all I've got to do is go through the process of solving for n, right? Remember, this radical 2 is a coefficient, so what's the first step here? Divide by radical 2. I'm going to cancel. Come over here, divide by radical 2. So that gives me n equals 30 over root 2, right? Now, contrary to what maybe sometimes what Math Excel is going to do, they might ask, write it to the nearest tenth. If I've got that, I could right away just type that in my calculator and round that to the nearest tenth. Does that make sense? But I don't think that's beneficial for other questions that Math Excel is going to present you, because in the next question or later on in another assignment, they might say, type in simplest radical form. Well, if I've always stopped at this point here, I've never practiced getting the simplest radical form, and then I'm going to struggle on that question. Does that make sense? So let's practice that here. How do I get rid of that radical on the bottom? Okay, so I'm going to multiply by that value, right? And that's just essentially multiplying by what? 1. So that turns into 30 radical 2 up top. And what's it turn into on the bottom? 2. So what do I end up with? 15 radical 2. And that's, remember, we solved for n. Look at my template. N is that side right there. If I match it up to the actual problem that I'm working on, is that the x that I'm asked to solve for? Yes. So x there is 15 radical 2. Obviously, this side up here would also be 15 radical 2. That idea, guys, of taking this picture and lay it on top of that one, that's what you're always going to do. Eventually, this is how I'm going to do it. I'm going to say, I know in a 45, 45, 90 triangle, this is n, this is n, this is n radical 2. If I put equal signs on all those things, does it give me somewhere an equation that I can solve? Right there. Okay. So if that expedites the process for you, use that technique, use that process. Any others from 8-2? 8? All right, 24 centimeters. So it talks about this. It says, what is the size of a square plate that can hold a chopstick? Oh. Huh? Looks like a square on my computer. That better? It does. My screen's like 16 by 9, and that one's up there is 4 by 3, so it's a little bit. So I got one more go. You guys count them? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Okay, so let me make that a little bit. All right, so that's our plate, right? Okay. Now, they want us to put a chopstick across the diagonal. So you guys know what chopsticks are, right? Yes. Okay. So I'm going to say, so it's just a straight stick, right? I'm going to lay it across the diagonal, and it doesn't want any overlap, so it's not going to hang over the side of the plate. If that's a square, what is this angle right here? 90 degrees. What is this angle right here? Okay, so what other type of figure is a square? Nope. It is a rectangle, but it's also along the same line, so a square is a rectangle, but it's also a rhombus. And that's what those markings up there and the sides are telling me. All four sides are the same. So that's a rhombus, and we had a theorem that said the diagonals of a rhombus do what to opposite angles? What do the diagonals of a rhombus do to opposite angles? So that red diagonal, the angles that it incorporates or that it touches, what is it doing to them? What is that diagonal doing to, say again? Yes. Okay, so that angle right there is getting cut in half by that diagonal, right? So if that angle was 90 degrees because it was a square, cut in half because it's the diagonal of a rhombus, it turns into 45. So in a 45, 45, 90 triangle, is that in? Is that in? The hypotenuse is in radical 2. And I believe they told me my chopstick was 24 centimeters or inches or whatever, probably centimeters, not inches, long. Okay? Is that an equation that's going to allow me to tell the dimensions of my square? Okay? So I'm going to solve that. I'm going to divide both sides by what? Radical 2. So I get n radical 2 equals 24. They just said we'll divide by radical 2. So we get n equals 24 over root 2. Okay? Now what do I need to do to rationalize that? So we get 24 root 2 over 2. What's that turn into? 12 root 2. Okay, so 12 root 2 is the exact answer, right? I was working with somebody last period, or no, walkout time today, and they asked me this question, and he just basically explained to me what it was. I didn't look at his math Excel, and we went through it, and I said, the answer is 12 radical 2. Okay? He typed that in, and it was wrong. Because he didn't read the blue instructions on that question. It said type in the nearest 10. Okay? But once I have 12 radical 2, can I type that in my calculator and get whatever decimal they want? Okay. So I think that's the best thing to do. Always find your simplified exact answer, and then if they want you to round it, you grab your calculator and do it. Okay? That's the benefit of a calculator, not to do the work for you, but to change your values into things that decimal-wise are maybe a little bit harder to deal with without a calculator. So Does that help?
Yeah.
All right, this is what we're going to do next. And upcoming chapters. They're going to say, what's the area of that plate? What's the area of that plate? How do I find area of a square? Yeah. So isn't this 12 radical 2 by 12 radical 2? What's 12 times 12? 144. What's radical 2 times radical 2? Oh, you didn't say 1. I thought you said 144. It's 2. So that gives me 2. So by knowing that diagonal, I know the area of that plate. Does that make sense? Okay, so that's some stuff that where this is going to go. This question will show up again, or a question very similar to it. Might not be chopsticks or whatever, but we'll be asked, based on the diagonal, can you manipulate the information so that you can find the area of a square, or in this case, maybe even just a rhombus. Okay, is that all right? Okay. That question is very common when they actually find the area of a rhombus. A lot of times they give you a rhombus that has some 30, 60, 90 degree angles in it. No, that's on 8-3. We can do that one though. Shayla?
Can we do number 14 on 8-2?
Yep.
Oh yeah, that one's hard to do that.
No, it's not.
Yes, it is. Yeah,
No, on the other 8.
The 30, 60, 91? Does anybody, and yes we can, but does anybody have anything from this assignment still that needs to be kind of hashed out? Feel comfortable with this one? Remember, this one is due tonight. Okay? This one was assigned on Tuesday. Tuesday was not a blizzard bag day. Traditionally, guys, the 30, 60, 90, I would usually only give about 1 or 2 days to work on that. But because it was a blizzard bag day, by law, I had to give you 2 weeks. Okay? So that's why that one's not shutting off for a while. So let's get into the 8-3 one. All right, sorry, not 8-3, 8-2, 30, 60, 90. Apologize. Preview. All right, so what was see? What was the number you wanted to see? 14? Let me do something first. I want to talk about this one first, because there's some algebra that exists in this one that I think is going to benefit us when we get to 14, and some of the stuff I want to talk about 14. Did anybody have trouble with question 6?
Oh my gosh, I did, but then I realized what I was doing wrong. So the 45, 45, and I was trying to do 3, 60, 90 for both of them.
Okay.
I don't know.
No, I'm saying why would you do that? Yeah, why would you do that?
All right. So what happens, guys? If I'm writing an inter-course exam, okay, and these authors of these inter-course exams kind of take the same approach, I want to know as much from you as possible. I want to know the most about you that I can in regards to your skill level and your proficiency by asking a minimal number of questions. If I ask you this question, you get this question right, does it tell me you have competency within 30, 60, 90 and 45, 45, 90 questions? Okay. Now, if you get it wrong, it doesn't allow me to kind of delineate and say you're bad at 45, 45, 90 or you're bad at 30, 60, 90. It just says you were bad. Okay? But if you get it right, it tells me you're skilled at both things. So what do they like to do? They like to write questions that force you to use multiple ideas together. Okay? I think a lot of questions in geometry are like puzzles. Okay? And with a puzzle, you never really know where to start, right? You just start taking some pieces and try to see if they fit together, correct? That's what we're trying to do here. You use the edges, okay? But you don't know which 2 edge pieces are going to fit together until you start trying some of them, right? Okay? So that's kind of what you have to do here. I don't know whether to start in the triangle on the left, start in the triangle on the right, or if the overall triangle is going to lead me anywhere. Okay? What I need you to understand is that this is not a geometric mean question like we had in Chapter 7. And some people in the past have want to try to approach it that way because do you know anything about that angle there? Okay, you know that dotted line is an altitude, but is this a right angle?
No. Yes. I don't know.
Well, that's 45 and that's 30. So that's 75, right? So there's that angle right there, 105 degrees. So some people approach this question and try, once they start finding some values, try to use the geometric means to solve it. But geometric means only work if that angle up there is a 90-degree angle, okay? Because it only works if this third side down here where C and D are is a hypotenuse, okay? But the picture is very similar to maybe its setup kind of looks like what we've done already in Chapter 7, but it's not, okay? But we do have two triangles there, right? We've got a 30, 60, 90 on the right. We've got a 45, 45, 90 on the left. Okay. Now, if I were to just look at the triangle on the right, let me just color it so it's a little bit easier to talk about. If we're focusing on just the blue triangle, remember what these 30, 60, 90, 45, 45, 90 templates provide us. They allow us to find all three sides by knowing one side, right? If I start this problem, and that blue triangle is all I'm looking at, do I know any of the three sides? No. Okay. So should I start there? No. Okay. When we're looking at these questions as being kind of like a puzzle, you're going to start where you know the most information. Okay. You know the most information in the white triangle, correct? In that white triangle, if I were to redraw that, it's going to look like this, isn't it? And when I overlap the white triangle with that template, what two things land on top of each other? Good. 3 radical 2 is going to equal n radical 2. So what's n got to be? N is 3. So when the white triangle and the template land on top of each other, this distance here is n, right? So what's that solve for down here? C. Okay. Now, you could have done this and found A first, but the way I do that, guys, I found C before I found A, right? In Math Excel, it might be structured where I type in A first and I have to hit enter before I can get to B. And I have to hit enter before I get to C. I don't know how it's structured, but some questions are like that. But you can't solve maybe for A right away. Does that make sense? So the idea is to look at the picture holistically, solve the picture holistically, then go back and type your answers in. And once you have all of them. Does that make sense? Okay, so that's 3. What's A going to be? Why? Okay, so the same. 45, 45, 90, they're both legs. They got to be the same. So does that now get me into the second triangle? Yes, that's the value that kind of bridges the gap between the two triangles. Okay, so now I know a value out of a 30, 60, 90 triangle. So if I redraw the template for my 30, 60, 90, so that's the blue triangle on the right. Across from 30 is always what? The smallest side, so it's got to be n. Across from 90 is always 2n, and across from 60 is always n radical 3. Okay. Now, if I overlap that with the blue triangle, what is n? N is 3. Okay. So what is 2n? 6. And does that overlap here with B? And then what would D end up being? 3 radical 3. Okay. Does that make sense to everybody? So now we've got those values. Now, I'm going to extend this a little bit because of where we're going in this course. I want to ask you this question because I've been in geometry courses, guys, where the teachers teach this stuff and they're like, well, you took Algebra 1, so you should know this. And when it comes up next in Chapter 9 or Chapter 10, you should know it, and I'm not going to teach it. Okay? But I'm not of that mindset. I think if I've got opportunities to teach you something or revisit something, I'm going to do that. Later on, the question is going to be, how long is that segment? What are your ideas? What would you do with them? You would add them. So 3 plus 3 radical 3, right? Does anybody want to make a statement about what we would do with that? Which 2 3s? Okay, so here's where I was telling you yesterday. Are we certain about that? Are you 100% confident in that? Yeah. You are? No. You're kind of on the fence. Hopefully you're on the fence with that. Okay, so then you're wrong. Hopefully we're on the fence, and we're not sure. Do we have the ability to take our calculator, type in the way we see it right now? Okay? Type it in. So I'll use Desmos here if I can find it. Do I have the ability to type in 3 plus 3 square root of 3 and get that number? Okay? So now you're telling me the way I can simplify that is to add the 3's that are out front, right? Okay, so that would be 6. And you're going to say probably then square root of 3, right? What do those two decimals tell me? They're not the same. So what's that tell me about what I thought I could do? It's wrong, right? It doesn't work. So that algebra of adding the numbers out front is not a valid approach. Does that make sense? Okay, so you can use your technology to confirm those processes. What do I do?
You put the 3 on the other side, like, 3 radical 3 plus 3.
Okay, so write it that way?
Yeah.
Okay, that's fine. And that'd be like saying like 2 plus 5, something is 5 plus 2, right? So like the commutative property of addition is fine. So either one of those is appropriate. My argument is here is, guys, you can't condense that any further. That is the way we would express that answer as an exact value. Okay? And the reason why, there's a couple different reasons why, and they're all kind of tied into being the same thing, but maybe we view them differently. If I have 3 radical 3 plus, let's say, just 2 radical 3, okay, what do those both have in common? A radical 3. So could I factor out a radical 3 and get something that looks like that? Take that bottom expression, radical 3 times that quantity. If you distribute that radical 3 through, do you get back up to what you started with? If I take radical 3 times that 3, does it give me that? If I take radical 3 times that 2, does it give me that? Yes, but now, if I break it up this way, what's 3 plus 2? 5 times my radical 3. Well, what's 5 times radical 3? A better way of writing that is that way, right? So, if I put in those two boxes, what do you think is an approach that allows me to go from 3 radical 3 plus 2 radical 3 to get 5 radical 3? What is the only thing that I really did there? How can I take that top box and get that bottom box? Add the outside numbers, right? Okay. Why? One, that distributive property, but another one is if I have 3, that says 3 times radical 3. Well, 3 times radical 3, multiplication is repetitive addition. If I have 8 times 3, that means I have 8, 3 plus 3 plus 3 plus 3 plus 3 plus 3s, right? All the way 8 times. Or I have 3 times 8, which would be 8 plus 8 plus 8, right? Does that make sense, everybody? Now, when I look at 3 radical 3, I would like to look at the fact that I have 3 radical 3's being added together, okay? Meaning that I can write 3 radical 3 as radical 3 plus radical 3 plus radical 3. Is that 3 radical 3's? Radical 2 radical 3 would be, so this one here would be radical 3 plus radical 3, right? Does that make sense to everybody? Okay. How many radical 3's do you have total there in that line? 5. Okay. So that's why we add that number out front. Similarly, if we had like 3x plus 2x, how would you write those? 5x, right? And we can envision that x is just our radical 3, because x is any number it wants to be, right? Okay. If I were to write this, can I add those? Can I combine those? No. In that situation, maybe x is radical 3, and maybe y is radical 2. If I had that expression, I can't add those together because there's not a like term happening there like it was with radical 3 plus radical 3 plus radical 3 plus radical 3 plus radical 3, right? Does that make sense to everybody? So when I'm adding radicals, the first thing I have to check is, are my radicals simplified? The next thing I have to check, are there any radicals that are the same? Because if there are, I can add their numbers up front. But if they're different, I just leave them as they are, okay, with the implied operation occurring between them, so that plus sign occurring between them. Is that okay? Yes. Yes. So that idea, guys, hopefully gives you an approach that when I'm on a test or a quiz in Algebra 2, because it's going to happen a lot to you in Algebra 2. It's going to happen to you a lot in your other math classes. And you forget a rule. Can I do this or can I not do this process? Take your calculator out, do it the way you think you can, and see if that produces a result based off of your initial values. Does that make sense? So if my 3 plus 3 radical 3 was my initial value, do I think I can change it to 6 radical 3? Evaluate both of them and see if they're the same. If they are, then yes, that rule works, so I can keep using it. If not, I got to figure something else out. Okay? I think that process is very useful if you understand how to use it. So the reason I wanted to talk about that question first and this question, where'd it go, last, is because this one at the end kind of incorporates that concept if we leave our answers at exact values. Okay? This question is, I'm just going to go off of memory here. It says that during a storm, a wall gets damaged, and the construction guys come in and they start putting braces up against that wall to support it. Okay? They put that first brace in that's 10 meters long, and they put it down, they nail it down to the ground, or stake it into the ground, so there's a 45-degree angle there at the ground where my cursor is right here. Okay? Then at that exact same position, they take a longer brace and make a 60-degree angle there. Okay? And that gives you that longer hypotenuse. Is that okay with everybody? So we got these two braces. I think if this was maybe color-coded, it'd be a little bit easier to deal with. But here's the question. Anyone know, the first question, it's a two-stage question. First question says, how long is the longer brace? Okay, so that would be that distance right there. They want to know how long that is. Okay, well, if I start to look just solely at that triangle, all by itself, so this is, I'm just redrawing. For me, I can just hide this stuff. If I look at just that 30, 60, 90 triangle with nothing else in there, that angle is 60 degrees. Do I know any information about that triangle to be able to tell myself what that hypotenuse is? No, I don't know that bottom ground distance, and I don't know how long it, how high it's touching the building. Okay, so those things are problematic for me. However, if I do something like this, do you know something about that 45, 45, 90 triangle? Yeah. In a 45, 45, 90, isn't this side always in, that side in, and what's the hypotenuse? N radical 2. So do you see that these two things would be equal? All right, so I'm going to go ahead and solve N radical 2 is equal to 10. Divide both sides by root 2. All right, so now they ask you to type your answer in as a decimal. So that's the answer. If I want to type in as a decimal, I can go through and do that. But I think it's important for us to simplify it, so let's go through and simplify it. Shayla?
How does that work? You can't have a root in the denominator.
You're right, but so because they asked me for a decimal, and to be honest, that's not the answer, because they want the longer brace, and that's not the longer brace. But if I look at this, 10 divided by square root of 2, it still evaluates, right? It's the exact same thing as 5 square root of 2 that we're going to find out here in a moment is the actual answer simplified. But this version, would you guys agree that if we could avoid fractions, we'd like to? So do you see how this process avoids a fraction here? Okay. So that's why we do want to simplify that. We call it rationalizing the denominator. So you are right that we do need to multiply that by radical 2 over radical 2. Gives me 10 root 2 over 2. So now what's going to happen with that 10 and that 2? Okay, so it gives me 5 root 2. Now, that solved for n, right? I think a lot of times when people are doing these problems, they forget that we're solving for n. They get this 5 radical 2, and they're, okay, now what was that? Okay, and they don't have the notation or the linkage between that and what they're actually solving for. But that was this distance right here, 5 root 2. This distance here is also 5 root 2, correct? Why is that useful? When I look back at that 30, 60, 90 triangle, do you now know a length of that 30, 60, 90 triangle? Well, I know.
Did you figure out the one?
I know this distance here, right? And if that's n, what is the hypotenuse of any 30, 60, 90 triangle? 2n. So this distance here is going to be 2n, which is just this number doubled, right? So if I'm going to double that number, what's that going to turn into? What's 5 radical 2 times 2? 10 radical 2. That's the length of my longer brace. Okay? The length of the longer brace is 10 radical 2. Now they ask you for it as a decimal. Radical 2 is 1.414. They want one decimal place, so it'd be 14.1. Okay? That's what they want for part A. Part B, they want to know, and this is, you got to pay attention to how they word this, because there are a lot of people in last class who kind of messed this up. Last class thought by the wording that they want to know the difference in that length compared to that length. Okay? If I were to ask that, if I was going to put that in words, wouldn't that be what is the difference in the length of the two braces, or how much longer is the longer brace than the smaller brace? If we go back to Math Excel and read the question says, how much higher on the building does the longer brace reach than the shorter brace? Does that make sense to everybody? So what they're essentially asking here is, do you have the capabilities of finding that little distance right there? Because that's how much higher the longer brace reaches than the shorter brace. And we do have that, okay? Don't we know in this 30, 60, 90 triangle, which would be that overall triangle, if this is n, if 5 radical 2 is n, doesn't this side here have to be n radical 3? Does that make sense? Across from 60 is always n radical 3. So if n equals 5 root 2, then n radical 3 is going to equal 5 root 2 times radical 3, right? What's that going to give me if I multiply that out? What's 5 times root 2 times root 3? What are your thoughts? What are your guesses? 5 radical 6. That is the answer, 5 radical 6. Okay? So now, you know that the short brace reaches a height of 5 radical 2 on the building. The long brace reaches a height of 5 radical 6 on the building. How do I find that little distance right there between them? What work would I do? What algebra would I do? Five root 6 minus 5 root 2. Subtract those two values, and you're going to find the difference between them, right? Okay? So that's kind of the approach that we have to use there. Now I was trying to erase certain parts of those figures, the certain hypotenuses, so that you can see just one triangle at a time, right? Obviously, you don't have that capability on your notebooks or whatever, so best thing I think would be draw a 45-degree triangle, okay, or 45, 45, 90 triangle. Right next to it, draw the 30, 60, 90. So they're separated. Does that make sense? And you can then, when you do separate them, kind of give you the idea of what I'm thinking about here. So maybe there's my triangles kind of stink. So maybe this is my 45, 45, 90. And then I draw my 30, 60, 90, okay, where this is 60, and that's 30. And the only thing I need to know is that that distance right there, when I separate them, and that distance, they are the same, right? They were overlapping in the original picture, so they should be the same when I separate them. And that should maybe allow me to kind of work through and find all those parts. Shayla?
Okay, so my little arrow, the number that's attached to that is 4.
Okay.
And I can't get this, I can't get this.
Okay, so if that's 4.
I got the first one just fine.
Okay. So that's 4. So then this would be, would you get 2 radical 2?
Yeah.
Okay. So 2 radical 2, 2 radical 2. Okay. So that would be, so that's 2 radical 2. That's 2 radical 2. This distance here would be 2 radical 2, right? Now across from 60 would be your n times radical 3. Well, this is my n for this 30, 60, 90, right? Multiply that by radical 3, you get 2 radical 6, right? Okay? So now the question is that distance right there. So how did you go about taking those two values? Okay. And that should give you, are you typing in as, I don't think I have that question up anymore. All right, so give me 16. So mine's going to be, this is going to be 8 root 2. Oh, sorry, that's 16. That's 16 root 2. That's the, they want the longer, what in the world? They want the longer brace. So longer brace is 2n. So if that's 16 divided by radical 2, oh, decimal. They want a decimal. So that's the thing. So I didn't read.
Hey, you got something.
All right, so 22.6. All right, so now it says how much higher does the longer brace reach? Okay, type an integer or decimal. So when you're, are you rounding to the right decimal place?
No, but I didn't add his radicals. I got it wrong.
Oh, okay. So you did the same thing I did. Now, that's the thing, guys. And I'm going to harp on you about doing it, but you saw that I did it as well. So I understand that. I understand it's, you get to a question like this, you say, okay, I just want to find the length, and the way we've been doing it in class is exact, or the way we've been doing it in classes we've been rounding. Whatever, you're programmed to think about one way of typing an answer in, right? You always got to pay attention to that, okay? And they're gonna bounce back and forth on purpose. Shayla?
So if you have 19, can you put 9.5 outside of a radical?
You can, but like if I'm going to do algebra later on with that, so like 19 over 2 radical, what you write, is it radical 2? Is it, are you getting radical 2 as your radical here, or is it radical 3? Okay, so that is equivalent to 19.5 radical 2. But predominantly speaking, usually we don't, because of the algebra that we're going to do later with that fraction, is going to be easier with the fraction than it is with the 9.5. Yeah. All right, so I think somebody asked about question 7 or 6, maybe. The one with the trapezoid. Does anybody know what question it was?
It's the one before that one, so it would be
13.
Oh, that's the one.
It's 12.
Did I show this class yesterday?
Yeah.
So you want to skip this one?
Yeah.
Did somebody say they want to see 13?
Yeah. All I did is multiply by 6. I don't know why.
The triangle in the shape of a 30, 60, 90. A lot of times that's called a speed square there a lot of times. You see maybe carpenters use those quite a bit.
Yeah. We
Says,
use them in the shop.
use them shop? Good. If the hypotenuse of the outer triangle is 43 feet, find the length of the legs of the triangle. All right, so I don't know why they get, the scenario here is kind of silly. I don't even need to, this is essentially just, I think this triangle in here is just trying to screw you up. Right? Because it says, if I read it, if the hypotenuse of the outer triangle is 43 feet, find the length of the legs of the triangle. They don't say anything about the inner triangle, right? So if that's my 2 in, right? The 30, 60, 90, that's 2 in. This would be in, so this would be 43 over 2. And this would be in radical 3, so it would be 43 over 2 times radical 3. Now it says simplify your answers, type an integer or a simplified fraction, type exact answers, use radicals as needed. That's exactly what you have to type in. Okay? You can't type in, what would be 21.5 radical 2. I don't think it's going to accept that because it's not a fraction. It's a decimal, right? Incorporating a radical. You can't type in the decimal. So you need to be able to kind of manipulate these things in all versions, decimals and exact values. Okay? Yes?
Okay, so my answer was 9.83, and it says round to the nearest 10. So I said 9.8.
Mm-hmm.
It says I'm wrong and it's 9.9.
I'll go back and give you a point for it. You're fine. Sometimes there are little things with Math Excel and the way they program things with rounding like that messes things up. But you're right, Shayla. I know new homework tonight. Make sure that you work on these. I know this second assignment's going to be over for a while. 8.2, the first assignment, closes off tonight. So make sure that is finished by 11:59 p.m. Yes. Yes. Tyler. Huh? So the shorter side is 43 over 2, and this is the longer side. You got the same exact numbers? You guys can go. Show me how you type it in.
That's good, right?
Oh. We're messing something here.
My coach.
See how it says 43 feet? And this is asking in inches. So everything we just found was in feet. So you got to multiply that by 12. So you're going to figure out what 43 times 6 essentially is. So the reason they're doing that is because it's going to get rid of the fraction for you. They multiply by 12.
What's the radicals assignment that you
It's going to be due on Thursday. It's just a review of algebra. You can do it whenever. Yeah. Yep. Just continue to practice that stuff. Been doing everything?
Yes.
Promise?
Promise. You got it?
That fixed things?